Hello and welcome back to the channel. Today we are going to start with optimization methods. So these are the contents that we are going to cover in this video. Firstly is unconstrained one variable function minimization that has 3 search methods into it. Then we will move on to multivariate function minimization that has 2 methods to be considered into it. Moving on to a quick introduction to optimization. So optimization involves finding the minimum or maximum of a function. Many real-world problems in engineering, machine learning, and economics require optimization techniques. Now let us understand it for a function fx, where we can classify optimization methods into 2 subparts, unconstrained and constrained. For unconstrained, let's say UC, that means that there is no restriction on x. And on constrained optimization method, we can have certain conditions that must be satisfied. Let's say gx should be less than equal to 0. So in this video, we focus on unconstrained optimization methods for both single variable and multivariate functions. Firstly, we will look at unconstrained one variable function minimization. These methods apply when optimizing a function with only one variable. The first one here is Fibonacci search method. So it uses Fibonacci numbers to determine the search intervals, making it efficient for function minimization. And it is quite similar to golden section search, but it reduces the interval size more efficiently. So the algorithm steps in the Fibonacci search method includes, the first one is to choose the initial interval A and B containing the minimum. The second step is that we need to compute 2 points x1 and x2. Using the Fibonacci numbers, x1 equals A plus f n minus 2 fn, and then we have b minus a. For x2, we can have it as a plus fn minus 1 fn b minus a. This is how you can compute these x1 and x2. Next, the step number 3 involves computing fx1 and fx2. Step number 4 is to update the interval by discarding the less promising region. And step 5 is repeating until the desired accuracy is achieved. So these are the 3 main steps in the Fibonacci search method. The advantages of this search method involves that it is more efficient than uniform interval reduction, and it works without derivatives. Moving on to golden section search. So it is a bracketing method that maintains a specific ratio for interval reduction. Based on the golden ratio, that is phi, nearly equals to 1.618. The algorithm steps in this search method involves firstly choosing the initial interval A and B. This is our first step. Next steps involve compute the 2 points using the golden ratio, and these are similar to the Fibonacci search, that are x1 and x2. For x1, you can have b minus a divided by phi, and for x2, you can have a plus b minus a divided by phi. Step number 3 is similar, computing the values of fx1 and fx2. Step number 4 is to update the interval by discarding the worst region. And lastly, we need to repeat until the interval is sufficiently small. And again, the advantages of golden section search is that it is a derivative-free method and more efficient than brute force interval search. Last for the one variables is Newton's method for optimization. Newton's method for optimization uses second-order derivatives to find the local minima. So the formula for Newton's method for optimization is xn plus 1 equals xn minus f dash xn divided by f double dash xn, where f dash xn, this part, is the first derivative, that is our slope, and the denominator f double dash xn is the second derivative, or we can say as it is the curvature. Algo steps in this includes, firstly, we need to choose an initial guess, that is x0. Then second step is to compute the next estimate using the formula. The last step is to repeat until convergence. Advantages are that firstly it has quadratic convergence, making it very fast, and it uses curvature information to make smarter updates. Whereas when it comes to disadvantages, it requires computing the second derivatives. That is quite complex in some questions. And it can fail at one specific condition, that is f double dash x equals 0. This is known as the point of inflection. Moving on to multivariate function minimization. These methods optimize functions with multiple variables. For example, fx1, x2, x3, and that can continue up to xn. That is a multivariable function. The first method is method of steepest descent or gradient descent. So it uses the gradient, that is vector of partial derivatives, to move in the steepest direction of decrease, and is commonly used in machine learning and deep learning. When it comes to algorithm steps, the first one is choose the initial point, that is x0. Then we need to update it using the formula xn plus 1 equals xn minus alpha delta fxn, where alpha is the steep size, or we can say it as learning rate. Lastly, the last step is to repeat until the convergence is achieved. Advantages are that it works for high dimensional problems, and it is very simple and widely used in AI/ML. Disadvantages include that it can be slow if alpha, that is our learning rate, or steep size is not chosen well, and it may oscillate or get stuck in local minima. Next is Nelder-Mead algorithm or simplex method. It is a derivative-free optimization method that is used for noisy or non-smooth function. It uses a simplex, that is a geometrical shape with n plus 1 vertices and n-dimensional spaces. Algorithm steps are that we need to start with an initial simplex, like triangle in 2D and tetrahedron in 3D. We need to compute the function values at each vertex. Step number 3 is to update the simplex by reflection, expansion, contraction, or shrinkage to find the minimum. Lastly, we need to repeat it until the simplex shrinks to a small region. Advantages are that, firstly, that it does not require derivatives and works well for non-smooth and non-convex functions. Disadvantages involve that it can be slower than the gradient-based methods and may fail in high-dimensional problems. Let's have a quick comparison of all the optimization methods. First, we had Fibonacci search that does not require a derivative. 1D smooth functions is the best suitable for it. Speed of this is medium. Then for golden search, similar things as the Fibonacci one. Then comes up Newton method and steepest descent. Both of them requires derivatives, and Newton's method is for 1D functions, whereas steepest descent is for multivariable and convex problems. Newton's method is very fast, whereas steepest descent has a medium speed. Lastly, we had a look at Nelder-Mead that does not require derivatives again and is suitable for multivariable, noisy and non-smooth problems and has a very slow speed. So these techniques are widely used in machine learning, physics simulations, finance and engineering. And that's all for this video. And I will see you in the next video with some other topic in computational methods. Until then, you find this video valuable for you, so please give it a like, share it with your friends, and subscribe to the channel to help us grow. And I will see you in the next video. Till then, happy learning.